This is a machine that we offer, a Robbins valve grinding machine. It has a precision chucking system where it holds the valve stem with six precision steel balls, and we're able to regrind valves or refinish new valves to within a tenth run out.
This and we can
Sure.
share these images because they're very, very descriptive of what's going on.
And here's some equipment. Um, Chuck, you're so good at this. Why don't you explain these two ways of measuring valve seats and why they're both important together?
Okay, and I usually, as I share this, a lot of folks are familiar with the Stephen Covey's um, Seven Habits, and one of those was synergy. And oftentimes one process is great, but you can take two processes and put them together and they're exceptional, right? So that one and one can equal three. And I think that's what used to be, referenced in that old training manual. But anyway, if you take a look at why to vacuum test and measure runout. So vacuum test is a good way to check machine, um, or the assembly arm uh, condition, but like the run out or the concentricity gauge, which you see, the top right, um, they can tell you things like if I have a machine that's out of level, they can tell you, uh, you know, if I have pilot size selection problems and things of that nature, but they may not catch the like chatter and undulation of the valve seats. Vacuum will not catch valve head deflection if you have nice uniform runout. So the machine cuts without any high frequency disturbances like chatter, then they vacuum test just fine. And I can have like 7 thousandths run out. Again, it goes back to what we were talking about earlier, where we can flex the valve head to the seat. Um, but what runout cannot capture is like a nick on the valve, debris, things of that nature. And what's really happening is the valve's not touching the seat. Well, that one little nick, oh, that's just a tiny little nick on the valve head, but it's actually holding the whole valve off of the seat. So those vacuum test very well, and you catch that. Um, Guide size and geometry can make it difficult, with the pilot selection. So again, it goes back to the how we started this presentation out. Guide size is paramount in importance. So it makes us look in the right areas for the true problems. But the valve seat runout, kind of a good rule is you should never allow your valve seat runout or concentricity to exceed what your stem to guide clearance specification is. So there used to be kind of the rule 1 thousandths per inch of valve head diameter. Well, what's the valve head diameter got to do with it? That's irrelevant. It's stem to guide clearance because if going back to the shape of that seat and the valve contacting one another, it's it's a wedge. So I'm going to say that my finger, is the valve seat. I'm trying to take two cone-shaped items and jam them together. So again, that with that pressure, I can flex, with the springs and the vacuum force, and they can be disguised. So again, 1 + 1 can equal 3. So most instances you can regrind those, and those are some options that you can have. So
Yeah, important to, again, measuring. We offer a very precise instrument that can measure valve runout in 10 thousandths of an inch. And this is a photograph of that instrument. This instrument can also be used to check if there's any runout on the stem, because that can also create some problems, bent valves, as it were.